Hello guys and welcome back to the SimpliCode programming channel. This is Vikesh and let's get started with today's topic, which is about exception handling in Java using try and catch blocks. So in the previous session, we had a look at the scenarios where an exception can occur. How do we see that there's a runtime exception or there's a checked exception or there's an unchecked exception or there is a custom exception. Now, we did not talk about how to handle those exceptions. And now we are going to focus on the handling part. So whenever you have to handle those exceptions, the way Java provides for that is using the try catch block. So try catch block is basically a bunch of syntax which you have to follow to handle different types of exceptions in your programming code. And the syntax of the try catch block is pretty straightforward. You write try and you put curly braces, and then you write whatever code which might throw an exception. You don't know that, but it's always safer to enclose your code in a try catch block so that you know that if an exception occurs in the try block, then you can handle it in the catch block. So it's always considered a better practice to enclose your application code in a try catch block so that you can handle the exceptions. So you put this try block and write all the suspicious or non-suspicious code which may or may not throw an exception inside the try block. Once you have done the try block part, then comes the catch block part. So let me go to the catch block. So this is how the syntax look like. Once you have written the try block, then you write catch and you put braces and you write the exception type which this block of code might throw, or the exception type which you are interested in catching. You might not be interested in catching all the different exceptions, but only a few ones based on your business requirements. So whatever exception type you want to catch, you are going to catch it like this. And if an exception occurs in the try code, let's say you have specified an arithmetic exception here, and if any line of code in the try block throws an arithmetic exception, then this catch block is going to catch that exception. And then inside these curly braces, you can decide what to do with that exception, whether you want to log that exception or whether you want to rethrow that exception, whether you want to embed some error code or get an error code out of it, or convert that exception into a business or custom exception of your own choice. So it's up to you what you want to do with that. But catch block will be able to catch that arithmetic exception. Similarly, you can specify as many exception types to be caught as you want and keep adding more and more catch blocks. Remember that these catch blocks work in a sequential fashion. So if an exception occurs here, it will first go to this particular block to match the exception type. If it didn't match, then only it will move to the second type. If it did match the first type, it is not going to execute the second type. So that is how the try catch block work. You can see an example here that if the code here is throwing an index out of bound exception, then it is going to be caught here. And we are just printing the index out of bound exceptions message. If it is throwing an IO exception, then I can do this. So you can keep adding different checked and unchecked exceptions in the catch block. You can also catch more than one type of exception with one exception handler. So rather than writing these multiple catch blocks individually, you can combine these exceptions together if your logic of processing both of these exceptions is the same. Remember, if the logic of processing these two exceptions is the same, logic means whatever you write inside these curly braces. So if that code is going to be the same for both of these exceptions, then why bother writing two catch blocks? Just write one catch block like this. Use the pipe operator to separate different types of exceptions and write the common code which is going to be applied if your try block is going to throw an IO exception or an SQL exception. So that depends upon you. That's the second piece. The third piece of the try block is the finally block. So we talked about the try block, we talked about the catch block. Now there's a finally block as well. Remember, this is finally and not final. The finally block is used together with the try catch block when you want to perform some cleanup operations. Imagine you are opening up a file handler in the try block, you're doing something with it, and then you want to just close the file handler irrespective of the fact if there was an exception in the try block or not. Because even if there was an exception, the file handler resource is going to remain open and is going to consume memory in your application. You don't want to do that. Similarly, if you opened a database connection inside your try block, irrespective of the fact of what happens in the try block, you always would like to close the database connection. And you can write that closing code in the finally block. That's the purpose of the finally block, that you can write the code inside the finally block, which is supposed to be always executed irrespective of the fact whether an exception occurs or doesn't occur. So now we have built a good understanding of what is the try catch, what is the try block, catch block, and the finally block. Now, if you just put it all together, this is how it is going to look like. That you write the try block, you do something inside the try block, then you write the catch blocks. After that, you write the finally block. You can write the finally block without the catch block as well. Remember that. If you do not have any exception to catch, but you have some resources to close or free up after executing the try block, you can skip the catch block and just write try finally. That is also possible. With that understanding, let's switch to the IDE and let's look at some example. So I have a writer helper class, which is having a method called writeList. I have a try block here, and this try block is basically initializing an array list, adding an item to the array list, and then I'm accessing list.get1. Remember when I added this particular value, let me make it 10 to make it more understandable. When I added 10 to this particular list, this goes to the index 0 position. And here I'm trying to access index 1 position, which does not have anything. So in such case, it might throw an error because there's nothing at list.get1. So this is my method where I put the try block code. And then because I don't want to end up in a position where I get an index out of bound exception. Index out of bounds exception comes if you are trying to access an index which is illegal, which does not having any value. So I'm putting a catch block and catching the index out of bound exception and just printing the message of the exception. And then for simplicity, I'm showing a finally block as well. Though I do not have any resource to close here, but this is just to show you how this looks like in the code. This is just to show you that I'm printing a sys out here. This is what my method is. And if I go to the main class, the try catch demo class, I'm creating an object of the writer helper class and calling the writeList method, which we just walked through. Let's run this program and see what happens. Okay, so first I get this statement saying entering try statement. So if I go here, I call this method, the execution goes inside the try block and I get this sys out, which says entering try statement. Then I try to access the second element in the list because the position is 1. This is going to index 0 and I'm trying to access index 1. There is nothing at index 1. So I get an error saying index out of bounds exception, index 1 out of bounds for length 1. Because the total length of the list currently is 1 because there's just one element and that one element is sitting at 0 and not 1. So I get the exception, which is the index out of bound exception, but the index out of bound exception is caught by my catch block and the system.error.println is something which gets executed and I get this particular line from this line number 17. And then irrespective of the fact whether an exception occurred or not, my finally block always gets executed. Let's fix this and see if the finally block gets executed even if there is no exception. So now I'm accessing get 0 and let's see what happens. Yep, I access the element 10, no exception, but the finally block still gets executed. So this is to assert our understanding that the finally block will always be executed irrespective of the fact whether there was an exception or there wasn't. Now you can also nest different try blocks if you want to. Let's look at an example where I have multiple try blocks. So you can write a try within a try within a try if you want, and you can go as deep as you want. But remember, the more indentations, the more hierarchy you create, the program is going to get more and more complex. So always remember to have that kind of trade-off. So I write multiple try blocks, I initialize an array, I print array 10. Obviously array 10 does not exist because this array has just 4 elements. So this is bound to throw an index out of bound exception, and I'm catching that exception immediately in the catch block. This is the exception, printing a sys out and just rethrowing the exception. You can also rethrow the exception by just using the throw keyword. Remember, this throw is different from the throws keyword, which comes in the method signature. This is just to throw any exception from your code. So this is array index out of bound exception for this try block. Then I have another array index out of bound exception for this try block, which starts from here, block 2. And then I have another catch block for the block 1 try block. So you can see it is already getting a bit complicated where I have multiple hierarchies, but you can do that. So this is what is happening in this particular program. Now let's try to run this and see what happens and try to decipher the output. Okay, so at first I get this particular line which says array index out of bounds exception in block 3. What happens here is that this line gets executed. It throws an array index out of bounds exception. At line 13, that array index out of bounds exception is caught, which was generated from this line. And then we go inside the catch block, we execute this sysout. This is what you see here, the same sysout, and then we rethrow the exception. If we rethrow the exception goes to the enclosing try block. The enclosing try block is this one. There was an exception rethrown from this try block, and now it has gone to this try block. And now this try block, block 2, will try to see if it can catch this array index out of bound exception. Yes, we can catch it. So it can. So the block 2 again has a catch block which catches the array index out of bound, and it prints a sysout here which says exception in block 2, which we see here. And it again rethrows the exception. And if it rethrows the exception, so now the block 2 is rethrowing the exception. So this whole code is now rethrowing the exception. If this block 2 is rethrowing the exception, it goes to block 1, just going one hierarchy up. And then it sees if it can handle the exception in the catch block of this block 1. So yes, the block 1 try block also had a catch exception which said array index out of bound E4, and here it just had a sysout. So if I just bring back the output, yes, we do get this particular exception printed here which says array index out of bounds exception in block 1. This is what you see here. And this is where the exception just stops going propagated, because I'm not rethrowing the exception from this particular catch block. So that's where the exception ends. The reason you see a hyperlink here is because the text which I have printed here exactly matches with the name of the exception. So Java is pretty smart in that case. If you use the exact same name exception, it will link it to the matching class name in Java, which is pretty cool. I also have a redundant catch block here, which does not have a try block. This is just to show you that you can write a catch block without a try block, but it doesn't make sense. It is of no use. So I can just remove this particular catch block and the program still will compile fine. So this was a quick demo to show you how you can use try, catch, and finally blocks. And when would you use the finally block? And if you want, you can use a nested hierarchy of try blocks, and you can rethrow the exception from within the catch block only to be caught in the outside or the outer or the enclosing block. So this is all I want to cover in this particular session. And in the next session, we are going to talk about one of my most favorite concepts in Java, which is about equals and hash code. If you like this session, a thumbs up would be massively appreciated. And please don't forget to subscribe to SimpliCode for more programming related videos. Thank you, and we'll meet again in the next session.